Hello everyone, I'm Mayuk Mukherjee. As you can see, I have tinkercad.com opened over here. In case you do not know, tinkercad.com is an online circuit simulator. So the purpose of this video is for my, or I'm recording this video for my peer graded assignment for the course that I'm currently pursuing on coursera.com. The course is Interfacing with Arduino by Professor Ann G. Harris of University of California, Irvine. So the goal of this project that I'm demonstrating in this video is we have to blink the or we have to turn on and off the onboard LED of the Arduino Uno, this LED, uh, by pressing either of the or triggering either of the two push buttons. So we have to use two push buttons, and on pressing either of those or clicking on either of those should turn on the LED, and uh, leaving it should turn it off. So as you can see, I have the circuit completed over here already. I'll first be explaining the circuit, which component is used and which is connected to what and why. Next, I'll be going over the code, how the code works, and at last, I'll start the simulation and I'll show how exactly the LED is turning on and off uh, on pressing the push button. I'll show that in real time. Okay, first of all, let's start by explaining the circuit. Before that, I'll tell or I'll say what components are being used. As you can see visibly, we are using the Arduino Uno microcontroller, which is connected to the power, to a power source via USB cable. The power source might be a laptop, a PC, or even your Android smartphone. Also, we have a breadboard over here. As you can see, we have two push buttons, uh, a resistor. In this case, we are using a 10 kilo ohm resistor and some connecting jumper wires. Okay, so first of all, let me explain something. Since the aim of this project is to use two push buttons, clicking on either of each will trigger the LED. We have to, I'll first explain how we have connected these two push buttons in series so that pressing either uh, will turn on the LED. In a breadboard, as you can see, there are many rows and many columns. uh, the rows are numbered by 1 2 3 4, as you can see. Say, let's say this is row 7. Okay, row 7 has 5 pins or 5 in let's say holes. Similarly, these are columns F G H I J. J Column J also has many holes, or let's say connection points. Okay, so in a breadboard, in each row, uh, all the 5 holes of each row are interconnected. So what I mean by saying this is that suppose you have two components, component A and component B, and these each of these two components has two terminals, terminal 1 and terminal 2. So component A has terminal 1 and terminal 2. Similarly, component B has terminal 1 and terminal 2. Let's say we connect terminal 1 of component A in this pin, and we connect terminal 2 of component B in this pin. So terminal 2 of component B and terminal 1 of component A will be interconnected. As I said, connecting or placing an wire or a terminal in each hole of either of these 5 holes of a row means they are getting connected together. These are internally connected, these 5 holes. It applies or it holds true for all the rows from row 1 to row 30 in this part and also in this part. So in order to connect these two push buttons in series, what we are doing is I'm removing the push button to show you how I placed it. We took the push button and we placed it over here. Okay, so terminal 1A is placed in G1 this, and terminal 2A is placed in G3 this pin. Okay. Also terminal 1B of this push button PB2, I've named this push button PB2 and this push button PP1. Also terminal 1B of PB2 is placed here. And as I said that all the 5 holes of a row are interconnected. So in this, terminal 1A of this push button is connected to terminal 1B of this push button 2. So terminal 1A of push button 1, this is push button 1, this one. Terminal 1A of push button 1 is connected to terminal 1B of push button 2, as they are connected in the same row. Similarly, terminal 2A of push button 1 is connected to terminal 2B of push button 2. Okay, so we have interconnected these two. So later on, it will be shown that pressing either of these two push buttons will trigger the LED. It doesn't matter which push button we are pressing. Now I'll explain the rest of the connection. So we have to okay, before that I'll explain the basics of the push button. So push button, as you can see, is quite simple. It acts as a switch. Clicking it completes the circuit or performs some action, and releasing it closes the circuit, opens the circuit actually. And as you can see visibly, it has four terminals, but it doesn't really have four terminals. It has two terminals, because this terminal and this terminal, these two are internally connected. Similarly, this terminal and this terminal, these two are internally connected. So we have to use either sides, either of the two sides. Okay, so we are using terminal 1A. To terminal 1A we are connecting power. By power we mean that we are connecting it to the 5 volt standard power of the Arduino. This is supplying 5 volt to button terminal 1A of this push button. As you can see from terminal 1A, there's from the next hole to which the terminal 1A is connected, from the adjacent hole we are connecting a red wire, and we are taking it over to the 5 volt pin of the Arduino. Okay, so and where is this Arduino getting this 5 volt from? From obviously from the USB power that is being supplied from the, say, laptop or PC, the device to which the Arduino is connected. Okay, also, so power is being supplied to terminal 1A, and terminal 1A is connected to terminal 1A of this second push button. Now we have to use the other end, other terminals, for the other function, which is the triggering of the switch. So we are connecting terminal 2A to pin 2 of the Arduino. We might have connected this to pin 4 or say pin 6, but in the program we are using pin 2. We could have used any other pin, but we are using pin 2 as the, say, trigger for the input. That is, the clicking of the switch or the pressing of the push button is being detected by the pin 2 in the Arduino. That is why we have to connect the terminal 2A to the pin 2 of the Arduino. And in the program also, I'll show you later on that we are using pin 2. We could have used some other pin, but for this example's sake we are using pin 2. Also, as you can see, we are using a resistor over here. So let me explain why we are using a resistor. In most of the components that we use in IoT devices and such projects, those components are usually, they have a very low current rating, say of the order of few milliamperes. What current rating means is that it is meant to function healthily when it is supplied with that amount of current, or at that level of current it should function healthily. If the specified amount of current or the current rating were to be exceeded, and if it were to be operated at values exceeding its rating, then it will die prematurely. So most of the components that we use in IoT devices like LEDs and switches and so on, they have quite low power rating of the order of few milliamps, quite low current rating. Okay, so we know Ohm's law. Ohm's law is basically V is proportional to I, or the potential difference or voltage across two ends of a conductor or a electronic component is proportional to the current flowing across that component or the conductor. So it means that if the potential difference is increased, or if the voltage across the two ends is increased, the current will increase. In these components, in the components that we use in IoT devices, the voltage remains constant. In some cases it's 5 volt, in some cases it's 12 volt. So if the voltage was to remain constant, and the current rating will also be constant, because it is characteristic of the device or the component that we are using. So the resistance, what resistance is being taken into account? Obviously the internal resistance of the component of which we are talking about, its current rating, that component. So as we are saying, these have a fairly low power current rating of the order of few milliamperes, and standard voltages are like 5 volt or 12 volt. 5 volt or 12 volt is quite high value for a component which has a current rating of few milliamperes. So what happens is that if we apply Ohm's law in a component that is being applied with 5 volts and which has a very low power current rating, it also, a component which has a very low current rating, it also has a very, generally has a low internal resistance. Let's say an LED has a very low internal resistance, especially when it's on. So uh, if the internal resistance is very low, and if the voltage 5 volt is constant, and if the current rating is of the order of few milliamperes, the internal resistance won't change its characteristic, and also the supplied voltage 5 volt is constant. So what will happen, in order to obey Ohm's law, that is V is equal to IR, the current I will increase exponentially, because the voltage is quite high, 5 volt, and the resistance, internal resistance will be very low, few milliohms or lesser than that. So the current will be quite high, very high, so much so that it will kill the component uh, within a short time, if not instantly. So in that case, what we do is we use resistors of different values, say in some cases 10 kilo ohm, 5 kilo ohm, 7.5 kilo ohm. So why do we use the resistor? We connect the resistor in series with that component, the component which we are saying that has a low current rating and a low internal resistance. So if we are connecting the external or a discrete resistance in series with the component, then we are adding the resistance of the external resistor to the internal resistance of that component. So the whole resistance is being taken into account. In that case, if the resistance is moderately high, say 5 kilo ohm or 10 kilo ohm, for that the voltage value 5 volt is suitable. In that case, the current rating of few milliamperes is maintained, as the resistance value is making up for the high voltage, which is 5 volt. And we use a resistor of such a value which will maintain the current flowing through the component close to or equal to its current rating. So according to that, we decide what value of resistor or how much ohm that resistor has to be. So that's the use of a resistor, in order so that the component isn't damaged through the passing of a high value of current. Okay, so that's the use of a resistor. So we are using a 10 kilo ohm resistor over here. We are connecting the resistor to the terminal 2A of the of this push button. It's similar to connecting to the terminal 2A of the second push button. As I told you, these terminals are connected together via the breadboard. So one end of the resistor is being connected to terminal 2A, and the other end of the resistor will have to be connected to the ground. How are we connecting it to the ground? We have taken it all the way to this pin. We could have kept it close by, but I'm taking it far away from this because I have to keep this part of the I intend to keep this part of the circuit clear. Uh, so for the sake of clarity, so we have taken it over to this pin, and from this adjacent pin, uh, placing the black over wire over here. If we place the black wire over here instead of here, it would have been the same thing as I explained. As you can see, it's highlighted in green, these 5 volts. These are all interconnected. So from here we are taking a black wire and we are taking it to the ground, GND of the Arduino. So essentially we are connecting this terminal 1 of the resistor to the ground of the Arduino, and the other end of the resistor is connected to terminal 2A. Okay, and as you can see, there's another purple wiring. This purple wiring is also going from terminal 2A to the pin 2. So pin 2 is detecting the trigger, that is when we press the switch, uh, we are turning on the pressing the switch, it is being detected at pin 2 of the Arduino. Now that's for the circuit. Now I'll explain the code. As you can see, this code, I haven't written this code myself. This code is I've copied it from the examples in the Arduino IDE. So from the Arduino IDE, this is the example to blink an LED. I'll be explaining the code. As you can see, in the first part of the code, we have declared two variables, uh, constant integer button pin is equal to 2. That is, this terminal 1A is being connected to this pin. So button pin is this one. This push button's button. This is connected to pin 2. Similarly, constant integer LED pin is equal to 13. The onboard LED of the Arduino, it is connected to pin 13 internally. Okay, so we are using pin 13 as the output, or uh, the function which will be performed on triggering of the input, that is the input which is connected to the pin 2, and the input here is the pressing of the push button. Okay, in the next part, uh, in this syntax, in this line, we have typed integer button state is equal to 0. In the comments, it's written variable for reading the push button. Okay, so button state is the variable that is used to read the push button state. So what do we mean by push button state? If the push button is pressed, it means it's on, the LED will blink. This means that the circuit is closed and the value of the LED is high. Similarly, it means that the value of the push button is high, or what it translates to is that if the button state, this variable is 1, it means that the button is pressed and the LED is supposed to blink. And if button state is 0, it means that the switch is no longer, the push button is no longer pressed. So the if the button state is 1, the LED will be set to high and the LED will blink. And if the button state is 0, it means the button is no longer pressed and the LED will be off. It will not glow. Now we start with the function void setup. We have written pin mode in brackets LED pin comma output. It means that the push button, the LED pin, it is set as the output pin. And similarly pin mode button pin comma input, it means that the button pin or the push button pin, it is set as the input or the trigger. So on the according to the state of the button pin, the LED pin will be uh, adjusted, like altered from one state to the other. Okay, so in the next function void loop, we have written button state is equal to digital read button pin. In the comments it's written read the state of the push button value. That is button state is equal to digital read. It will, the Arduino will read the button state whether it's 1 or 0. If it's 1, it means the button is pressed, and if it's 0, it means that the button is the push button is not pressed. Okay, so this syntax, it means the Arduino is reading the state of the push button whether it's pressed or not, that is whether it is 1 or 0. Next, in the next line we have written the loop to check the condition, that is if the push button is pressed, the LED will blink. If it is not pressed, the LED will be off. Simple if else loop. It's written if button state equal to high, digital write. Okay, digital write is the command to toggle the, you know, some function on the Arduino. If button state equal to high, it's double equal to, because it's checking for a condition. So if the button state is high, this variable is high means 1, then digital write LED pin will be set to high. Else digital write LED pin comma low, means if the button state is low, then the LED pin will be set to low, that is the LED pin 13 will be off, means the LED will be turned off. Okay, quite simple program. We don't write else if button state equal to low, because there are only two conditions here. If the button state is high, the LED will be on, and if it's low, it will be off. So we just write else LED pin will be set to low. That's for the code. Now I'll be starting the simulation and I'll be showing exactly how it's functioning, this circuit. Okay, I clicked on start simulation. As you can see, the simulation has started, and the onboard LED, not the onboard LED, the power LED on the Arduino is on. It means that the circuit is on, and as you can see, this power is connected over here. The It's graphically showing that it's connected. So I have two push buttons. The aim of my experiment was, or the aim of this project was, pressing either of the two push buttons will turn the LED on. So I'll start by pressing this push button. As you can see, I have kept it pressed and the LED is on. I'll leave it right now and it will turn off. See, it has turned off. I'll press it again. It's on. Leaving it will turn it to off. If I press this push button rapidly, the LED will blink accordingly. See, if I go faster, more frequent, as you can see, the button is the LED is blinking according to how fast or how frequently I press the push button. Similarly, if I press this push button, it will also perform the similar function. That is, it will also pressing the push button will turn the LED on and leaving it will turn off. And this is happening because these two are connected serially. These two push buttons, push button 2 and push button 1, are PB2 and PV2 are PV1 are connected serially. Okay, so that's it. And if you don't press any button, the LED will be set to off. So that was the experiment, quite a simple project. I hope I have been able to explain. I have performed it. Uh, Thank you for listening. I'll be stopping the video here.